Okay, since there was so much information in this section, we're going to do a graphic organizer to keep track of all these logic statements. So let's remind you on what we mean by conjunctions and disjunctions. Again, conjunctions was and, disjunctions was or statements. So if we have this P and this Q, and we're going to do the conjunction of P and Q. That'd be, again, P says vertical angles are congruent, Q is 15 as a prime number. So the conjunction of that would be vertical. I'm going to abbreviate a lot of stuff. Vertical angles are congruent, and 15 is prime. Now, reminder from, and you remember our truth tables, conjunctions can be true, they can be false. In order for an and to be true, then they must both be true. Vertical angles are definitely congruent, but 15 is not prime. So since they are not both true, then this is a false statement. The disjunction here would be P or Q. And we're going to do the same thing. Vertical angles are congruent, or, since it's in a disjunction, it's an or statement, 15 is prime. In order to be a true disjunction, since it's or, at least one has to be true. Since this is true and this is false, at least one of them are true, so therefore the final truth value on this would be a true statement. Conditional statements. A conditional. Here we've got, says P, it says it is St. Patrick's Day, and Q is it is March. So a conditional statement looks like this. P implies Q is going to be the way we're going to set this up. So P was it is St. Patrick's Day, and Q is it is March. So that would be St. Patrick's Day would imply that it is March. And since we know that St. Patrick's Day is in March, if it is St. Patrick's Day, then that would imply that it would have to be March. So that would be a true conditional. To find the inverse, the prefix in means not. So we're going to not the P, we're going to not the Q, so we're going to do not P implies not Q. So if it is not St. Patrick's Day, then that would imply that it is not March. And let's think about this one. If it is not St. Patrick's Day, well, St. Patrick's Day does not run the whole month of March. Just because, what if it's March 1st and it's not St. Patrick's Day? That doesn't mean that it's not March. So just because it's not St. Patrick's Day does not mean that it's not March. Okay, now converse. To find the converse, we're going to move. We're going to switch the P and Q. So that would be, instead of P implies Q, the converse would be Q implies P. So that would be, we're going to flip-flop these two up here. So if it is March, that implies then that it's St. Patrick's Day. And again, it's the same as before. Just because it's March, there's 31 days in March, so there's 30 days that are not St. Patrick's Day. So just because it's March does not mean that it's St. Patrick's Day. So that would be a false statement. Next up, a contrapositive. Now, to find a contrapositive, if the original statement was P implies Q, to find the contrapositive, we're going to switch and not. We're going to do not Q implies not P. So scrolling back up, not Q, we could actually just take this statement, which was Q implies P, and we can not the first and not the second one. So if it is not March, then that would imply, let's say not March, would imply that it is not St. Patrick's Day. And as you think about that, if it is not the month of March, if it's April, May, June, July, August, if it's one of the other months, then that would definitely imply that it is not St. Patrick's Day. So that would have a truth value of true. Now, something we hit on in the video, and now let's go ahead and solidify that it is true. If a conditional statement is true, and this one was true, you see it here. If a conditional statement is true, the inverse and converse don't have to be true. However, the contrapositive will always be true. And I'm going to say it again because it's so important. If a conditional statement is true, the contrapositive will always be true as well. And finally, the biconditional. If P implies Q was your original, then the biconditional would say that not only P implies Q, but also Q implies P as well. It works both ways. Or the way we abbreviate it is that P implies Q and also Q implies P. And that would be if it is March, then that implies that it is St. Patrick's. Well, or if it, excuse me, that was, if it is St. Patrick's, that implies that is March. Let me erase that. Was the original statement. So if it is St. Patrick's Day, then that implies that it is March. And we said a while ago that, yeah, that's true. But to be a biconditional, that would also mean that the converse has to be true, which means if it is March, that would imply that it's St. Patrick's Day. And you can scroll back up and see the converse. Converse was false. So therefore, since you're in the biconditional, since your conditional was true, but the converse was false, that means your biconditional would also be false.